So here's the second part of the lesson for today on limits. And we have a table of values, and I'm going to actually go to Desmos to help me complete this table of values so I can see it better. So I'm going to go to Desmos right now, so you can go to Desmos with me. And so here's Desmos, and I'm going to type it in. So because you don't have your graphing calculator right now, maybe you do have it, you can practice with that. I'm just going to use Desmos when we do this. So I'm going to type in, and I'm going to write it as a function. So I'm going to write down f at x equals, and then a fraction, which is the divide sign. And we got x subtract 8, and then in the denominator we have x squared plus 4. All right, underneath I'm going to fill in the table this way. So I'm going to type in, like, what's the value at 1.997? And you can see the answer just popped up. So 1997, that's negative, and we're just going to go to 3 decimal points. So 0.752. So as I'm looking off of Desmos, just know that I'm also filling in the table of values at the same time. So we're going to go back and forth. So next is 98. So it's negative 0.751. 99, as we're getting closer to 2, that's negative 0.751. Now how about the other side? So it's 2.001. So as I fill that in, that's negative 0.0 or negative 0.750. 0.002, that's negative 0.749, and then 3. And then we'll just look to see what did we discover with this table of values. So I filled in the table of values. And so what's happening as it's getting closer to 2? What answer are we getting closer to? And the same thing to the left, what answer are we getting closer to? So we have negative 0.751, negative 0.750. It clearly seems like it's getting closer and closer and closer to a certain answer. Now, what would happen if I actually plugged in 2? What would the answer be? So if I just plugged in 2, the answer is negative 0.75. And when I look at the left and I look at the right, can it seem like, yep, that's the answer it's getting closer to? So from the left, is that the answer it's getting closer to? Yes. From the right, it almost seems like we're almost there at 2.001, and that you can see the right and the left both agree at what the answer is. Now you might say, hey, why don't I just substitute in and get the answer? And that's a great thing. I think you should. But there are situations where you can't substitute in and get an answer. Instead, you have to plug in numbers very close to it on either side to get the value that you're looking for. So this one says, estimate each limit using a table or a graph. And what I'm going to do is I'm going to tell you simply is that you can do this estimation, if you can, by substitution. And if you can't do it by substitution, then yes, we're going to go to a table or a graph to see what it's approaching. So if I look here at number 9, can I simply plug in the answer? So where there's an x, can I plug in 4 and see what the answer is? Well, that's 12, take away 2, and that answer is 10. Substitution, done. And I got my answer. And you can see it's linear, and that's exactly what it's approaching. Here, negative 1. What would happen if I simply did substitution? Can I get the answer I'm looking for? So I'm going to plug in negative 1, and I get 2. take away 1, take away 4. That's negative 3. The first rule to evaluate a limit is to use substitution to find the y-coordinate. There are just situations that you cannot do a substitution. We're going to look at them right now. So 11, you can still do a substitution. So for 11, can you plug in? Wherever you see a negative 5, or an x, put in negative 5. If you want to, you can go to Desmos, right? As we're doing it to get the answer. So for this one, I would type in negative, oops, let's get to the second box. I would type in negative, parentheses, negative 5, it's cubed. Move the cursor. Subtract 4, parentheses, negative 5, and this one is squared, plus 7, parentheses, negative 5, and then plus 9. And it's calculating as you go along, but you can see the answer is negative 1. Number 12. Now, if I take negative 3 and I substitute in, what are you seeing? Well, if I substitute in here, I want you to know that negative 3 squared gives you the answer 9. And if I substitute on top negative 3 to the exponent 3, this answer here actually gives me 0 over 0. So substitute in, and what answer do you get? 0 over 0. This is called indeterminate. So I can't just substitute in to find it. So one way to solve this is with the graph. So I'm going to go here with the graph, and I'm going to type it in. So let's get rid of this. So I'm going to graph it, and I'm going to start with the divide sign. I can call it something, so I can call it f at x equals. And then in the numerator, I have x cubed, subtract x, subtract 12. In the denominator, x cubed plus 27, sorry. We'll give it the wrong one. And then in the denominator is x squared, subtract 9. Now, if I try to know what the value is at negative 3, so if I plug in negative 3, what do I get? It's undefined, so I can't do it that way. If I look off my graph with Desmos and go, okay, let's trace it. See how I can trace along? So I like press down on the curve. As I'm getting closer, oh, I passed. So as I get closer to negative 3, can you see what the y value is around negative 3? So as I get there, negative 2.99, I get negative 4.493. If I go on the other side of it, at negative 3, it's undefined, and you can actually see a hole there. If I'm like, you see the hole there? On the other side, it's negative 4.515. So negative 4.5 on the other side, negative 4.5 if I am rounding it. So what is it approaching? What's the y value when x is negative 3? What is it approximately off this graph? And so I'm going to go back and say the answer is approximately negative 4.5. We're going to find a better way in our next lesson by algebra to find it exactly. So this answer is negative 4.5. Let's look at the next one. I'm going to plug in 4. Well, if I plug in 4 on the bottom, I get 0. And if I plug 4 in, I get 16, take away 4, take away 12. I get 0 over 0. Again, it's indeterminate. So I don't know what the answer is here. So I'm going to use my graph in this case to do it. Now, maybe I'll do a different way with the graph this time. So let's go to our graph and type it in. So I have f at x here. This time I have x squared. This is what's on top. Oop, let me get the fraction line here. So x squared, subtract x, subtract 12. In the denominator is x subtract 4. Now I want to know as x approaches 4 this time. So if I just put in 4, you're going to see the answer is undefined. So off my graph, let's look at it. or do a table. So let's say that I do a table. I haven't done this, so let me try that. So let me do a table, and let's say that I'm going to change this to f at x, and change this to just x. Will it let me? No. So let's change this to y1 equals, and then change this to y1, and then change, will it let me do that? Y1 equals. It's not letting me do what I want. How about if I just did y? Oh, there we go. Just x and y. So if I put in 1, will it give me an answer? If I put in 1, oh, there it goes. So I could do a table here. So if I plug in 1, I get 4. Now, what am I looking for? As x approaches 4. So what's a number super close to 4? Like 3.9? What would it give me? How about 3.99? What would it give me? How about 3.999? And is the answer on the right getting closer and closer to an actual number? Certainly looks that way. Now, if I just plug in 4, what's going to happen? Undefined. So I don't know what the value is at 4. How about on the other side? If I plug in 4.01, what would I get? How about 4.001? How about 4.0001? So as I look at it, and I look at the y value, look on the right and the left, what y value is it getting closer to? So the closer I get to 4, the closer I'm getting to what answer? And the answer is 7. That's what I'm getting closer and closer to. So let's go here and put in this answer is 7. All right, number 14. What happens when I plug in 0? Well, I definitely get 0 over 0. So I need to find a limit a different way. So we're going to use a table to find a limit. So let's type this in. Now that I know I can do it that way, I'm going to change this. So the numerator for number 14 is x squared plus 2x. Let me change that. The denominator is x cubed, subtract 7x. No, x cubed subtract 4x squared plus 4x. Now, if I do a table here, so I'm going to do a table again. Let's see if this works. So I'm going to use x and y1. Oops. There it is. It just takes a second to kick in. So I want to know an answer close to 0. So on the left side, I could plug in negative 0.1. Or I could plug in negative 0.01. Or I could plug in negative 0.001. How about even closer? Negative 0.0001. So you know if I plug in 0, it's undefined. But as I get closer to 0, what's the answer approaching? In fact, on the graph, you can see these little dots happening right there. So as I'm using the table of values, these points are showing up on my graph. What does that look like that it's getting closer to? It sure looks like it's getting close to 0.5 or a half. How about on the other side? So positive, but close to 0. So like 0.01 or just 0.1 I could do. So 0.1 or 0.01 or 0.001 or 0.0001. On the right side, what else is it getting close to? So 0.1, 0.01, the closer I'm getting to 0 again, what's the answer on the right side getting closer to? Also looks like it's 0.5. So left and the right, they both agree what y value it's getting closer to. And I'm going to round it. So now I can put my answer down. So for here, what's the limit? What is it getting closer to? And the answer is 1/2 or 0.5 using table of values and Desmos. All right, let's get this. What's the limit as x is approaching 1? So again, if I plug in 1 on the top and 1 in the bottom, what do you notice? It's 0 over 0. Not undefined, but indeterminate in that I can still find the limit of that by seeing what's approaching on the left and right. So let's go back here, 2 decimals together, and let's type it in. So I'm going to type in y1 equals, I'm going to do a fraction line. In the numerator is x subtract 1. In the denominator, square root x, move the cursor, subtract 1. I want to do a table. And I want to use x and y1. Give it a second. Maybe it'll kick in. Now, I want values that are close to 1. So on one side, if I'm going from the left, I could put in 0.9. That's close to 1. Even closer to 1 would be 0.99. Or how about 0.999? Or 0.9999, right? Closer and closer. But if I get to 1, I don't have an answer. But what does it look like it's getting closer to? What's the y value getting closer and closer to? Well, it looks like it's 2. But let's look on the other side. So what happens if I put in 1.1 or 1.01 or 1.001? 1.0001. Does it look like the right is also getting to the same answer? And if you look off the actual graph, you can see the points that are gathering around what y value. So both sides agree the answer is 2. All right, 2 more like this where we're using a graph to determine the limit of something. Notice it's not equal to it without a limit. If I just plug 1 in, we don't have an answer. But if I see what the y value is as it's approaching it from both sides, I can see what the answer is that way. All right, number 16. Can I just do a substitution here? So 2 to the negative 2 plus 3. That's not 0 over 0. That's an answer. So what is a negative exponent? Well, that just means you do the reciprocal. So 2 squared is 4, but the reciprocal is 1/4. How do I add that? Don't make it complicated. It's 3 1/4. You could also write that as 3.25. And just by substitution, I can get that answer. So my first step is, can I plug it in? So plug in 3. 9 take away 15 plus 6. That's 0. Plug in 3 in the bottom. 9 take away 21 plus 12 is 0. So I can't get a value by doing direct substitution. So I'm going to use a table of values. So let's go back here and let's see the table of values here. So I'm going to type this in. y1 equals. I'm going to do a fraction line and I'm going to type it in. So if I type it in, I get x squared subtract 5x plus 6. In the denominator is x squared subtract 7x plus 12. So if I do a table again, it's going to be x, so I'm changing that to x and changing this to y1. Give it a moment. And then what x value am I looking for? So as x approaches 3. So I know 3 will not give me an answer. So less than 3, 2.9, 2.99, 2.999, 2.9999. What's the y coordinate getting closer to? -1. But I got to try the other side as well. So 3.1, 3.01, 3.001, 3.0001. What is it also getting closer to on the left side? Both. If you round it, the answer is the same, which is -1. So this answer of what the limit is, the answer is -1. Notice if I did a direct substitution, no answer. But I'm not looking for that. I'm looking for what is it getting closer to from both sides of that number, and do they agree? Now, a limit can fail to exist, and that means the left and the right do not agree. So the function contains what's called maybe a jump, so that it goes and then it jumps to another y value. Example 1 is one of a jump. And you can't see it maybe as clearly, but I'm going to fill it in. Can you see at 0, there's a jump. It goes from here and then jumps to another one. The limit doesn't exist there because the right and the left don't agree what the y value is. There are two different answers there if I plugged in numbers around 0. So at 0, the limit does not exist. Hey, did you ever watch the movie Mean Girls? You know, the one that, what's her name? I forget her name now. Lindsay Lohan, that's her name. And that she's actually in calculus, and they have what they're called mathletes. At the end of the movie, they are in a competition, a math competition, and she's competing at the end, and they give her a limit question. And believe it or not, the one girl on the other team thought the answer was something but was wrong. But she remembered that in this question, the limit does not exist, and she won everything. There you go. If you've ever watched the movie Mean Girls. Does not exist. All right, example number 2, you have an asymptote. Now notice in this example, and this is when x approaches -2, that the right side and the left side do not agree. The right side is going up and the left side is going down, and they don't agree on the answer. Another one, as it approaches 0, is it could oscillate. It could go up and down, up and down, up and down, up and down, up and down as it gets closer to 0. So the right and left don't agree because it keeps going up and down, up and down, up and down like a trig graph or wave going up and down. So those are some situations to look for where it would not, the limit would not exist. All right, turn the page or the next page. So can you estimate each limit and see if it exists or not? So when we estimate a limit, the first thing we're looking for is a substitution and whether the substitution gives us an answer or not. So I'm going to substitute in. So the limit as x approaches -1. So what happens when I plug -1 into the top? When I plug -1 into the top, -1 squared plus 1 is 0. When I do a substitution into the bottom, -1 subtract 2, well, this answer is -3. This answer up here is 0. Do they agree what the y value is, what the answer is? Because they don't agree, it does not exist. Let's do that over here. Plug in 2 on top. That's 4 times 2 is 8, so the top is 6. Plug 2 into the bottom. 2 squared is 4 plus 2 is 6. Does the left side and right side both agree what the answer is? Yes. And so we can write down the answer is 6. 20. Can you plug 3 into the top? That's 9 plus 3 is 12. Take away 12 is 0. And if I plug 3 into the bottom, the answer is also 0. So I need to do a table here to try to figure out what the answer might be. So back here to Desmos, and we're going to do a table. So we're going to go y1 equals, with a fraction line, and it's x squared plus x subtract 12, and then -3x squared plus 12x subtract 9. So there's our graph. If we did a table to help us, we would have x and y1. Give it a moment. And then we want values around 3. So like 2.9, 2.99. Or on the other side, which would be 3.01, 3.001, 3.0001. Do they both approach a similar answer? And you can see that both, on both sides, if you round it, is getting closer and closer to either -1.16 or -1.17. Let's try 2.999. And what is it approaching? 2.999. Just keep going and then think, what is it approaching, getting closer to? Is it going to be negative 1.17 or negative 1.16. And so as it's getting closer to 3, I think a good estimate here would be negative 1.17 from both sides. 21. So I'm just going to type in 21 since I'm here. So for 21, we have x squared plus x subtract 12. Same thing. And on the bottom, we have negative 3x squared plus 12x minus 9. Same thing. So good. I don't need to do that. But this time it says x is approaching 1. So I want to notice that at 1, what's happening? So let's erase these. And then think, what's happening around 1? So at 1, it's undefined. But happened before 1. So at 0.9 or at 0.99, what answer do we get? How about on the other side? At 1.01 or 1.001, are we getting the same answer on both sides? And can you see that one answer is giving me a positive answer and it's getting closer? So 0.99999 is getting huge. But if I put in 1.00001, that in the other direction, it's actually getting negative, and on one side, it's getting way positive. So for 21, you would say that this limit does not exist, because as I plug in values before 1 and after 1, they're giving me two different answers. One answer is negative, the other answer is positive. They are not coming together to an answer, so the limit does not exist. All right, let's look at this one, 22. So let's type it in. Y1 equals, and we have x cubed subtract x. In the denominator, we have negative 3x squared plus 12x subtract 16. Now, I want to know what the value is as it's approaching 1. So, what is it at 1? What happens if I wrote it as a function? So, exactly at 1, the answer is 0. What did I type in wrong? X cubed subtract x. Negative. Oh, I typed it in wrong. That's why it's not giving me what I'm looking for. Ha. It was 4x squared. I'm thinking something's wrong here. But I was looking off the graph. 4x squared plus 12x subtract 60. Now we're looking at something. So what's happening at positive 1? So at positive 1, it's undefined. So if I look here and trace along, at positive 1, it is undefined. So what is it getting close to on either side? So if I look on the left side, 0.09. If I look on the right side, it gets closer and closer, like 1.08. So could I round it to 1.1 both sides? Or 0.1, I should say. Could I round both sides? So like left side and right side. Could I round to 0.1? Just look at the y coordinate. So what is both sides getting closer to? And the answer is 0.1. So we have negative 1.17. It doesn't exist. And 0.1. All right, let's look off this graph. See if I can make sure I'm looking at the right one. So for this one, I'm just going to look off the graph for this one. So it is x squared plus 3x plus 2. And in the denominator, now the absolute value sign here, I think I have to go to functions. Oh no, it's right there. Here, where a is. So absolute value, of x plus 1. And what I'm looking for here is when it's approaching negative 1. So do you see negative 1 here? What's happening to the graph at negative 1? And I want you to notice there's a jump. So at negative 1, in terms of it, that there's a jump there. I also want you to notice that when you plug in, this one actually is undefined. Like negative 1 is a number. It's 1 plus negative 3 plus 2. Is there that? All right, so it is 0 over 0. But I want you to see a jump here at negative 1. You see the graph, and then it jumps, and then the graph continues. Because at negative 1 there's a jump, we write down it does not exist. All right, I'm going to continue with a third video that will complete this, and then we'll be done our assignment for today.